Hey y'all, it's me, Miss B, and today we're talking about inverse variations as well as using joint and other variations. So you should get out your do I have to mow the whole thing worksheet while we're going through this. All right, and so here's a copy of the graph you should have created for area of a rectangle with 24 units. So it's decreasing like so. So go ahead and answer, how would you describe this graph? Okay, and so then how would you describe the relationship between length and width? For A, you could have put a lot of things. You could have said it's decreasing. You could have said Y is decreasing as X is increasing, all that kind of stuff. And then for the relationship between the length and the width, the length increases, the width decreases, and if the width increases, then the length decreases. Okay, and then the equation that would represent this is, we're talking about an area of 24 units, so X times Y is equal to 24, where X is the length and Y is the width. Okay. So then we have our, for typists, it says that, I want you to go ahead and answer, as the number of typists increases, the number of days, what? And you should say that the number of typists increases, that our days are decreasing. Okay, and then go ahead and answer this next one. As the numbers of days decreases, the number of typists increases. All right, and then go ahead and talk about the equation for the function on your own. So the equation for the function is going to be your, what did we have? I can't remember. We had, I believe it was X times Y equals 36. Okay, so what this relationship is called is the inverse variation. So that was what was just represented. Okay, so the inverse variation, here's the equation for it. We've got X, Y equals A, or Y equals A over X. Okay, and A is called the constant of variation. All right, does this relationship look similar to something we've seen before? Should say yes, direct variation. Okay, they look very similar, except Y is equal to AX for direct variation. Okay, so we're going to go through and identify the types of variation here. For this first one, I've divided by X, so because of that, we have inverse variation. I'm just going to write inverse for this one. For this one, I have 1/4, which is a fraction, but the X is not in the denominator. That means that this is going, so this is my X and A is 1/4. So this is going to vary directly. All right, for this one here, x and y is in the denominator, so this is going to vary inversely. For this next part, I'm going to actually add 3x to both sides first. So y is equal to 3x. Now if we look at this equation right here, then this is going to vary directly. For this one, we'll subtract x from both sides. So y is equal to 5 minus x. Because of this subtraction right here, then this is going to be neither, actually. It's not going to be either one. All right. And then finally for this one, y and z vary directly because there's that multiplication there. All right, so showing the data as inverse, direct, or no variation, there is a test for it. So if it is the inverse, what we're going to do is we're going to multiply each pair. So if I have the inverse, then that's x equals xy equals a, then I'm going to get y equals a over x. So no addition or subtraction there. And then with direct, we divide each pair. So this is y equals ax, and then I end up dividing, so I have a equals x over y for that. Did I do that right? Yes, I did. Okay, so that shows us our thing there, it's talking about a. So between these, let's look at our relationship. So I've got 2 over 9. Well, so I've got 2, 4, 6, and 8. So my numbers in the width are going up, but then my height, 9, 4.5, 3, 2.25, all in order, are going down. And because one is going up and one is going down, their relationship is inverse. Okay. If I multiply these two numbers together, like I was talking about before, so 2 times 9, I get 18. 4 times 4.5, 18. 6 times 3, 18. 8 times 2.25, you guessed it, is 18. So that's how we know they vary inversely, because we get the same number every time. All right. So for this one here, my values are going up each time, and they're going down this way. So let's go ahead and do some multiplication. So 10 times 30 is 300. 20 times 15, so 15 doubled is 30, times 10 is 300. 30 times 10 is 300. And then 40 times 7.4 is 296. So that one right there is in the red zone. That does not work. So this is actually going to be neither relationship. Okay. And that's all for today.